here that a medical test designed for all kinds of stuff, an adult drinks 7 ounces of a 30% glucose solution. So that's the one that they make. They manufacture it. But if they have to give a child this test, they have to decrease the concentration. So we need to mix together the 30% solution and some water to make the same volume, a 7-ounce solution, but of a weaker solution. So we have 2 different fluids that we're dealing with here. We are dealing with the 30% glucose solution and we are dealing with water. We need to figure out how many milliliters of glucose solution. We need to know how many milliliters of water. Ounces. How many ounces of 30%? How many ounces of water? So there's 2 things we don't know, which means we're going to need 2 variables. So I'm going to call X my ounces of this stuff, ounces of 30% solution, and I'm going to call Y my ounces of water. So I have 2 different solutions. Sometimes we'll have a 30% solution and like a 1% solution. Sometimes it'll be a 40% in a water. It could be a 20%, a 5%. We can use whatever amounts we have here. So if I know we for sure need to wind up with 7 total ounces, I need some of my 30% solution, I need some of my water, but grand total, I need 7 ounces. Yes. So our first solution, or our first equation, and this is the easy one, is going to be that I need my X and my Y combined together to make 7 ounces. The tricksy one to wrap our brains around is the how we get it to be a 20% solution. I know that this guy, our X, that's a 30% solution. What percent does this have of glucose water? 0. It's a 0% solution. So if it helps, you can think of this as a 0%. So I know if I have some 30% solution and some water, I need to make the 20%. But the amounts matter. So if we have our 30% solution, you can either do that as 0.3 for 30%, 0.30, or you can think of it as 30. I tend to think of it as a decimal, just because I'm used to thinking 30% as a decimal. But it's going to be 30% of our X. We have this many ounces. So if I have 30% solution and I have 1 ounce, I have 0.3 ounces. If I have 2 ounces, I would have 0.6 grams or whatever this is measured in. If I had 3 ounces, I would have 0.9 ounces. So we're taking whatever our concentration is, including our volume. So we're going to have percent of ounces. And then we need to combine that with our water. So we're going to have our 0% solution. So you can do that as 0.0 times our Y. And we need to wind up with a 20% solution. So 0.2, and remember this is percent ounces, percent ounces, percent ounces. So 0.3x, 0.0y, 0.2, 7. That 7 over here is the most forgotten piece on these. So make sure we have percent ounces, percent ounces, percent ounces. If you are anti-decimal, totally fine. You can also think of this as 30x plus 0y and 20 times 7. Still will work, and it gets you to the same place. It's just less decimally. Because water doesn't have any glucose in it.
Wouldn't that just cancel?
Yes, I was just putting it up, so we made sure not to forget that when we were looking at stuff. So this is giving us a system of equations here. And yeah, we definitely noticed that this y is going to cancel out. So this is the exact same thing as if I had 0.3x equals 0.2 times 7. What's 0.2 times 7? What's 2 times 7?
14, so that would be 0.
Yep, 1.4. Because 2 times 7 is 14. 0.2 times 7 is 1.4. Moves over 1 decimal point. You can again also think of that as 3x equals 14. That's the same thing. So, what could I do now? How could I figure out my x and my y here? Divide by 0.3. You could get this to be common denominators. You can get this to be, you could multiply it by 10 to make it be whole numbers. However you want to do it. But we can divide both sides here by 0.3. What are we going to have for our x here? Think of it as yeah, this is going to be same thing as if it was 14 over 3, and that doesn't simplify. We could have it as 14 thirds. You can put it as 4 2/3. You could do 4.667. I'd rather us have it be either 14 thirds or 4 2/3, however our brain thinks about it better. That tells me how much of this 30% solution we need. We need 4 2/3. There we go, my brain stopped. 4 2/3 ounces. We can measure that. We get third of a cup measuring scoops. We get third of an ounce measuring scoops. Like, we can measure that. They're probably doing it by weight, but we can do that. So how much water do we need? Careful. So think about, we know this guy. I know my 14 thirds plus something is going to equal 7. 7 thirds. Because if we, again, common denominator, 14 thirds plus something is going to equal 21 thirds. Subtract the 14. Our y is 7 thirds, or 2 1/3. So I would need 2 1/3 ounces of water, and I need 4 2/3 ounces of the adult solution, the grown-up solution, in order to make this be a safe dose for kid. So when we're looking at these pieces, especially when it's looking at the chemical ones, because they love to pull these chemical ones. Percent volume for all of them. So we need to include our total amount of fluid. And then to get the ratio right, either do the percents and volumes, or you can set it up with whole numbers. Either way is fine. So these ones are weird and awkward, and I encourage you to definitely practice those. And there is one like it on the homework, I believe. 14. I was going to look at it. 14 is very much like this. Okay, so just be careful and be intentional with how we put these things together. This piece right here tends to be the most forgotten piece. If you forget this, things get all kinds of wonky. So make sure we're including the same, basically, I think of it as scale. So percent ounces, percent ounces, percent ounces. They all need to have the same thing. This is ounces, 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 percent ounces, percent ounces, percent ounces. Okay, we have one more of the story problems, and then we'll be done with story problems. Thank goodness, I know. Last one of the story problems. This is the last of 2.2. I feel like it ends on a slightly easier note. I don't think this one's harder. We've got Ada begins riding her bike on the Monon Trail. Ooh, relevance to our neighborhood. What? And she's going at a constant rate of 8 yards per minute. 15 seconds later, Holly begins at the same point on the monon, going in the same direction, going 11 yards per minute. So we want to know how long until Holly catches up with Ada. So we've got two people here. And again, if we're not sure what's happening, draw a picture. So I've got two people here. And yeah, they're riding bikes, but you'll see how I draw. I can't draw a bike. It looks weird. They're just riding giant binoculars. So we know Ada begins riding along the monon at 8 yards per minute. So she's going to go this way at a speed of 8 yards per minute. If Holly was taking off at the exact same time, we could just rock and roll and write these equations because we know how she's moving. But Holly waits a little bit. And then she starts going. So we need to figure out, for our equations, to be able to figure out when they're going to meet each other and get to the same spot, I need to know how far Ada is along the line, or along the road, before Holly starts going. So if Ada begins riding at 8 yards per minute, and we have to wait for 15 seconds, how much of a minute is 15 seconds? A quarter. So if she goes 8 yards in a minute and we need a quarter of a minute, how far did she go?
2 yards.
So, 8 yards per minute. And she's going 1/4 of a minute. 8 times 1/4 gives us 2 yards. Yes, we see that? So instead of Ada actually starting at the same place as Holly, she's really starting 2 yards ahead. So how can I write an equation for Ada and how she's moving? How does her position change? What? Definitely we're going to have something with the 2 and something with the 8. Which one of those changes every minute? The 8. And this 2, does it change, or is that just how far ahead she is?
Every 15 seconds.
Not every 15 seconds. It's just that. It's just when Holly's not moving. So we just have this plus 2. Because that's just saying they're not starting at the same spot. I mean, it's not long. So if we're on the one on trail, Ada's starting here, Holly's starting back here. She's going a little bit slower, but she's going faster. So we want to know when they're going to catch up. Ada started back here, but she was going before Holly started. She was like, oh shoot, my shoe won't clip into the pipe. Oh shoot, oh shoot, oh shoot. And it's a race. She's way ahead. She does not, her shoe wouldn't clip it. So now she's ready to take off. And we want to know when they're going to meet up. So this is the expression for how Ada's going. She got to start a little bit ahead because her shoe wouldn't clip it. Or whatever. How do we write an expression for Holly? How fast she's going? She got, oh, finally, I'm clipped in. Let's go. What's her expression? 11x. Because she's not starting ahead. She's just starting from the zero line. You could 100% set it up as 8x and the 11x minus 2 if you want to do it that way. Totally valid. But we want to know when they're going to get to the same spot, when they're in the same position. So I want to know when our 8x plus 2 is going to exactly equal our 11x. When they get to the same spot. Because this is the distance that Ada travels, and this is the distance that Holly travels. Bless you. So what do we do to solve this? Subtract 8x. We're going to get that 2 equals 11 minus 8 gives us 3x. So how long until Holly catches up with Ada? 2/3. 2/3 of a minute. So if they're not starting at the same place, we need to take that into consideration. If they're starting at the same place, we're ready to rock and roll. So 2/3 of a minute.
45 seconds.
That's 3/4.
Oh, wait.
About 40 seconds.
No. I was close.
Close. And especially when we're talking in seconds, it's not that big of a difference. If we were talking hours, then it would be a bit of a difference. Okay, so these story problems are weird and they take mental space.
That would be 40 seconds.
Mhm.
Done.
It would be 40 seconds. Okay, so these kind of medical style problems, they love to look at. We will see those pop up every now and then. Very similar pieces to this. So I encourage us to practice this one. It's a thing. So we are going to leave story problems. Yay! And we are going to remember some other things we know. We're not going to have anything super duper new right now. But I want us to remember our quadratic stuff because we struggled with this a little bit. So we are going to think about solving some quadratics. So we're going to look at two. This is technically the start of section 2-3. Just so we're clear. 2-2 is all story problems. It is just story problems. So this is 2-3. We're going to start talking about quadratics. We're going to be looking at quadratics and getting back into some of these solving things. Because we looked at quadratics with our factoring, but that was before when we were dealing with expressions and we didn't have equal signs. Because now we have equal signs. Now I can get all the way down to a solution where we have an x equals. We may have more than one. Because whenever it says solve, if it says solve, that means we want to get all the way down to an x equals. If it says simplify, that's when we're not crossing the equal sign. We're just simplifying as it is. And we can only multiply by funny looking ones. If we are solving, we're crossing equal signs, we're ready to rock and roll. So we're going to have times when we have more than one answer here dealing with our quadratics. So if we think about x squared equals 49, how can I figure out what x is?
Square root.
Square root both sides. As long as I do the same thing to both sides, that's totally valid. What are we going to get? What does x equal?
Plus or minus 7.
Good catch on that one. Plus or minus 7. Because I can either take 7 squared as 49 or negative 7 squared.
I did it right.
49. You did it right. You did it right. Because we know 7 squared is 49 and negative 7. 1 squared is also 49. So we're going to have times when we have plus or minus. And you can write it as plus or minus 7 like this, or you can split them apart and have x equals 7 or x equals negative 7. What about this next one? X squared equals 45. What can I do here? Again, we can do the same thing. Square root both sides. That's going to give us that x equals our plus or minus. And then 45 is not one that we necessarily know off the top of our head. If you know that, excellent, I love it. Otherwise, we're going to have to look for a perfect square that's inside of it. So something like 9 times 5. 9 times 5 is 45. I didn't change my expression. I just made it shaped better so that I can deal with it. Because with radicals, I can take this and I can split this apart into square root of 9 and square root of 5. Square root of 9 we know. Yep. So this is x equals plus or minus 3 root 5. Because root 5 does not come out tidy. I know that the square root of 4 is 2 and the square root of 9 is 3. So it's going to be closer to 2-ish. But aside from that, I don't know what it is off the top of my head. We don't need them as decimals. Unless we specifically tell you to put it in decimal form, leave it in simplified radical form. Then let's look at the one on the right. Square root both sides on this one because I have a perfect square on the left and a perfect square on the right. This is going to let me get rid of this exponent up here. So we're going to have our x minus 4 equals what?
9.
What? What is it? Plus or minus 9. Whenever we do that square root, the square root's what causes the plus or minus. Because it's what's unsquaring that gives us those two possible options. So our x minus 4 is positive or negative 9. But I don't want x minus 4 equals, I need an x equals. So since we're going to have to do an operation, now I'm going to split this into two expressions. So I'm going to give myself a little barrier here because they're getting a little close together. So I'm going to take my x minus 4 equal to positive 9. And I'm going to have my x minus 4 equal negative 9. What do I do with these to try and get my x by itself? Add 4. I need to add 4 here and add 4 here. And then I also need to add 4 here and add 4 here. That's going to give us that our x equals, what do we get on this purple one? 13. And what do we get on this pink one over here? Ooh, careful, careful. Negative 5.
I said that.
But not everybody did.
Oh.
Because we'll fall into that trap easy peasy because we'll be like, oh, positive and negative 13. That's why it matters where the plus or minus comes in. It does not get to the end and put a plus or minus. Here is where it becomes plus or minus. The square root is what causes that. We only really need to check for extraneous solutions if we're going to have an x in the denominator, or if we have a radical in the original expression. Because when we have x squareds, that's going to be, think about our parabolas. We're going to have a positive and we're going to have a negative. It's if we're dealing with things like square roots, because remember that's our inverse function of square roots where it goes like this. Square root functions, we could have our extraneous, which would be where it was the other side of the parabola, that kind of guy. So you can, 100% valid to check, but we're really only going to see those when we start getting into things like rationals or square roots as our expression. Which we will see eventually, but not right now. Okay, questions on these three? Because I know it's been a second since we solved quadratics. We're going to practice some more. Because we are going to need to be able to use the quadratic formula as well. I know. Which means we need to know the quadratic formula. Again. So I'm going to put it up here. 100% valid. If you need to sing the song. I'll join. Because we need to know our quadratic formula. Our x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a thing. It's there. We need to know it. So this one specifically tells us to solve using the quadratic formula. And we can always double check it and see, is it factorable? Is this something we could do something with? No, we would need it to multiply to make a negative 8 and add to make a negative 3. And I can't think of a set of numbers that multiplies to make negative 8 and adds to make negative 3. So this one does not factor anyway, so we would have to use our quadratic formula to find our solution. Unless you want to go completing the square, but this one is a really aggressive choice for that. When we're thinking about our quadratic formula, we need to make sure, first things first, before I start pulling my a, b, and c out, what does it need to equal? 0. Has to, non-negotiable, not optional, must equal 0 first. So this one's already set equal to 0, so we are ready to rock and roll. What is our a? 2. This guy's our a. What's our b? Negative 3. And what's our c? Negative 4. Those are the pieces we're substituting in. So I highly recommend when we're simplifying this, working it in chunks, just because it's really easy to get things mixed around. I always substitute pieces in without simplifying them, because it's really easy to get our signs misconstrued and they make a huge difference. So just be careful. Make sure we're being careful here. So our b squared minus 4 times a times c. There's my root and my fraction all over 2 times my a. So I like to color code it. I like to put everything in parentheses when I substitute them in and go from there. When we're simplifying, I do highly recommend simplifying your discriminant first. Remember this guy under the radical? That's going to make things easier if we simplify this in pieces as opposed to just going full tilt boogie trying to do the whole thing at once. I'm not saying you have to do it this way, but I feel like it is kind of an easier way to go, to simplify this in pieces instead of trying to do everything at the same time. There's some things we can do at the same time, because what is the opposite of negative 3?
3.
Positive 3. That we can simplify. Plus or minus our square root. Negative 3 squared. 9. Minus 4 times 2 times minus 4. Positive 32. Be careful on those signs. If you think about this as negative 4 times negative 4, we'll get a plus 32. If you think about this as 4 times 2 times negative 4, hush your face. If you think about this as 4 times 2 times negative 4, you'd have a negative 32 and you'd have minus negative 32. So depending on how you think about this as negative 4 or as positive 4, watch your signs. That's the place I see the most mistakes, is on that middle sign in your discriminant. So be super careful. And over our denominator, which we know 2 times 2 is 4. We know that one. So we're trying to simplify this. Well, 9 plus 32 we can do. What is 9 plus 32? 3 plus or minus square root 41 over 4. Does 41 have a perfect square as a factor? No. So we would check, say, is it divide by 4? No. Does it divide by 9? No. Does it divide by 16? No. Does it divide by 25? Really no.
Is it,
So it doesn't have any perfect squares inside of it, so it doesn't really have a simplified way to do it.
is it,
Yeah, 41, I believe is prime. I can't think of any factors that it does have. So that's our answer. We're going to leave it in our simplified radical form here. If we needed it as a decimal, we would type that sucker in the calculator. Because, ew. But this gives us our 2 different roots. We're just getting 2 irrational roots. It's 3 plus the square root of 41 divided by 4, or 3 minus the square root of 41 divided by 4. It's 2 real roots. They're just irrational. We're going to do the same thing on the right one. We've got 6x squared minus x equals 2. What do we have to do first? Subtract the 2. It has to equal 0 first. Not optional. Must. So we've got to subtract that 2 first. So we need to get this to be our 6x squared minus x minus 2 equals 0. Has to. Not optional. So then we can put this through our quadratic formula, same exact way we did before. We just have a different a, b, and c. So this time we have our a as our 6. We have our b. What's our b? Negative 1. And our c?
negative 2.
Negative 2. We're going to put all those pieces in to see what happens. So we've got negative 1 plus or minus the square root of our negative 1 squared minus 4 times 6 times negative 2. Oop, nope, I got my exponent, but that's okay. All over 2 times our a, which which is 6. We should always have 2 B's, 2 A's, and a C when we substitute them in. And again, I always will substitute them in without doing any simplification in this step. It lets me take a real quick spot check that I've got my A's in the right spot, I've got my B's in the right spot, and I've not lost track of any signs, and I've got my C in the right spot, and I didn't lose track of any signs. I highly recommend it. I'm not going to say you have to, but it is the easiest way to stop from making mistakes, is if you write it without simplifying anything first. Because then we can come through and simplify all kinds of things. Because we're going to know our -1 times 1, -1 times -1, giving us a positive 1, plus or minus. And we're going to have in our radical -1 squared, which is a positive 1, minus 4 times 6 times -2. We get a positive 48. And 2 times 6 in our denominator gives us a 12. So by simplifying, we get it here. Well, then I see more things we can simplify here because we have our 1 plus or minus the square root of 1 plus 48 is 49, which we do actually know. What is the square root of 49? 7. So I can keep going. We can simplify this more. X equals 1 plus or minus 7 over 12. If we have something that we can simplify, we're going to get all the way down to number answers. So we're going to split this apart. We're going to do 1 plus 7 and 1 minus 7. I'm going to change the view real quick. There we go. So we need to get our 2 different answers here. We're going to have our x equals 1 plus 7 over 12. And we're going to do our x equals 1 minus 7 over 12. What is 1 plus 7? 8. 8 over 12, does that simplify?
2/3.
2/3, both divisible by 4. We have 2/3. How about on our right-hand one here? What is 1 minus 7?
6.
-6. Watch your signs. -6 over 12 simplifies down to be what? -1/2. So sometimes we will get irrational values. Sometimes we'll get rational ones. Sometimes things will be nice and tidy and easy peasy. Sometimes they're going to get a little chaotic. This one, if we had looked way at the beginning, we actually could have factored this one, but we didn't. It said to use the quadratic formula, so we did that. But it would factor.
It would?
Multiplying to make -12, adding to be -1, so it would be a -4 and a positive 3. We would wind up with 2x minus 1 and 3x plus 2 as our factors.
I'm gonna be honest. You lost me like.
It's okay. You don't. We were told to do it with quadratic formula anyway, so we followed our instructions. So sometimes we're going to do it with factoring. Sometimes we'll do it with quadratic formula. Sometimes they won't tell us which one to use, but we can figure it out. So let's look at one more. Last one.
Shoulder.
And then tomorrow we'll practice solving with our factoring stuff.
Z.
Okay, if we don't like Z, switch it. Rewrite it with an X and just at the end, put it back. That's okay. You can switch it. If we go, ew, Z's gross. You can, quadratic formula, go through, plow through just like this with our 3/2 or -4 and -1. Absolutely valid. There is a way to make this easier. I have an equal sign. I can do the same thing on both sides. It genuinely does not matter what I do. So if I want to get rid of that denominator, what do? Multiply by 2. Everything. Oop. This guy times 2, this guy times 2, this guy times 2, this guy times 2. Everybody gets times by 2 because then my 2 and the denominator cancels out and we're left with 3. I'm going to keep them as Z's. If you generally hate the Z's, switch them to X's. It's okay. 4Z times 2 is going to give us an 8Z. Minus 1 times 2 gives us a 2. Equals 0 times 2, 0. This will have the same solutions as the one above it does. They're not equivalent expressions, but they will have the same solutions. As long as I do the same thing to both sides of my equal sign, I can do whatever the heck I want. This one's going to be easier to deal with. Multiply everybody by 2, and then it's a lot easier to deal with. I mean, you can go through it with the fractions. It works. It's just unpleasant. Because once we switch this to be tidier decimals, all it changes in our quadratic formulas, instead of saying x equals, it says z equals. And after that, it's exactly the same thing, where we're going to have our a, we're going to have our b, and we've got our c, which I used up that color. There we go. C. So same exact process. We're going to substitute our pieces in. Opposite of b plus or minus square root of our b squared minus 4 times a times our c, which is negative 2 over 2 times a, 3, like this. We found all of our pieces. And then we can simplify it. C equals, we're going to have our positive 8 plus or minus the square root that has our negative 8 squared. We get 64. Minus 4 times 3 times minus 2. That's positive 24. Over 3. Right? Am I wrong?
It's 6. 2 times 3.
4 times 2 times 3. Oh, the denominator. Yeah, there we go. Yep, yeah, 6. Sorry, I was focused on my numerator here. I was like, did I miss that one up? What? Times 2. Okay, cool. Just making sure. So we get, as our z here, z equals 8 plus or minus the square root of 88 over 11. 6. My brain broke. I was thinking 88 and that being 8 times 11. I don't know why, but it popped in my head. So
Isn't there a square root of 2? I mean, not a square root, common.
we can simplify here. Square root of 88 does simplify. It has a multiple of 4. I could rewrite square root of 88 as 4 times 22, right? So I could rewrite this as square root of 4 times square root of 22, which is the same thing as 2 root 22. Yes. Yeah.
Yeah, 2.
So I can put my answer, my z, as our, where are we? 8 plus or minus 2 root 22 over 6. Is there things common between both numerators and our denominator? 2. 8 divided by 2, 2 divided by 2, 6 divided by 2. So our fully simplified version of z, which I'm going to get it up here. We're going to have our z equals 4 plus or minus the square root of 22 over 3. Because this guy's divisible by 2, this guy's divisible by 2. When in doubt, think about how much we love to divide. There's a lot of stuff in here. But that is the start of 2-3. We're going to keep working with that tomorrow. Have a great rest of your day. Happy Tuesday. See you tomorrow. Bye. Hang on. I was going to say 2-2. You should be able to get finished hopefully tonight. There's only 6 questions on it. I'm going to try and talk us through registration tomorrow, but since internet has been up and down, I wasn't going to bank on it today.